Hello and welcome everyone. Very happy that we're all together again. In this tutorial, we will start talking about the protection system properties. So fasten your belt and let's get started. The aim of this tutorial is to learn about the required properties for any protection system. So there are some properties that we need to analyze to know what is the performance of the protection system or how the protection system can perform well according to those properties. So let's go ahead. First of all, if we need to collect the different properties which are discussed for any protection system, we say that they are the dependability of the protection system, which measures the degree at which we can depend on the protection system, and the security of the protection system, which measures how the protection system is a secure one, and also the reliability of the protection system, which measures how the protection system is a reliable one or we can trust it. Then we have the selectivity, which measures how the protection system can select the right action to perform or which protection system is selected to trip the circuit. And also we have the sensitivity, and the sensitivity measures how the protection system is a sensitive one to detect the sensitive fault currents. And also we have some other properties of the protection system like the adequateness, the speed of the protection system, the stability of the protection system, and the economics. So we will illustrate all of those 9 properties in details in this tutorial and on the next one. And let's start now with the dependability. Here the dependability is the ability of the protection system to break the circuit in case of there is a fault in the system. Or at all times there is a fault, the measure of the number of times the system can break the fault is the dependability of the protection system. And for that, it's a percentage that has this formula. Here it's equal the number of times at which we have a correct trip of the protection system when there is a true fault happens over the number of the desired trips, which are the number of times there is a true fault in the power system, and we must trip the circuit at which. Or in other words, if there is a fault occurs at that point, for example, it's the number of times that the protection system will break the circuit when the fault occurs over the number of times there is an actual fault and we need to break that fault. Also, the second property we have is the system security, and the system security measures the number of times that the protection system breaks the circuit by mistake. So at that time we need to know how the protection system can work wrongly, or we care about the correct tripping times. And this is called the security of the system. So the more secure is the system, the less wrong operations of the protection system. Or the more secure the system, the more right operations of the protection system to break the circuit. And the security equation equals the number of correct trips, which is the true fault in the circuit, over the total number of trips including the correct and the incorrect trips. So we say that the dependability is similar to those two contacts in parallel, where we care about the working operation of the system to trip the circuit, as if only one contact is closed, it's sufficient to trip the circuit. So we must trip the circuit at any probable fault, although it may not be a true fault. But on the other hand, the security is represented by those two series contacts because those two contacts must be closed at the same time to trip the circuit. So here we care about the protection system security, where we must be sure that there must be a true fault to trip the circuit at which. And after that, the third property of the protection system is the reliability, and the reliability is the ratio between the number of the correct trips to the number of the incorrect trips plus the number of the desired trips. So the reliability is a measure of the times at which the protection system has to trip the circuit in case of there is a correct fault to the number of times at which the system breaks the circuit when there is no fault. So it's the incorrect trips plus the number of the desired trips, and the number of the desired trips is the number of the truly trips plus the number of times there is a fault but the system doesn't trip the circuit. So those are the desired trips, which are the total number of trips that the protection system should work at them. Very good. Now we can discuss an example to apply on those first 3 concepts. Suppose we have an overcurrent relay that is working in the power network, and through a specific year we find the performance of that protecting relay to P, The relay operated 20 times, and out of those 20 times, we have 16 times were correct trips, and the relay failed to trip 5 occasions. So at those information or using those information, we need to compute the dependability, the security, and the reliability of the relay. And for that, we can extract the givens to P. We have a total number of trips to P 20, and the number of the correct trips of them is 16, and the number of the desired trips equals 16 plus 5, because those 5 times are the times that the relay doesn't detect the fault or it doesn't trip the fault, but there were an actual fault. So those 5 times are added to those 16 times of the correct trips. So the correct trips plus the 5 times that the relay will have to trip at them. By adding those two numbers, we get the total desired trips. And finally, we have the number of trips that the relay fills at them. Here they equal 20 minus 16, where 20 is the total number of trips and 16 are the number of the correct trips. So we have 4 times that the relay fails to trip the circuit at them. Very good. Now we can compute the dependability to equal the number of correct trips over the number of the desired trips. Here the number of correct trips were 16 and the number of the desired trips, we have detected them on the previous slide to P21, and this ratio is multiplied by 100. This is to give the percentage. So we have a percentage of the dependability to P76%, and then the security equals the number of the correct trips over the number of the total actual trips. Here it's equal 16. We have detected it on the previous slide over 20 times 100, which equals 80%. And finally, if we need to detect the reliability, it's equal the number of the correct trips over the number of the desired trips plus the number of the incorrect trips. So it's 16 over 16 plus 4, which equals finally 80%. So by that way, we managed to detect the performance of that overcurrent relay for its first 3 parameters: the dependability, the reliability, and the security. And from those results, we can conclude that when the number of the correct trips increases, we say that the device is a dependable one, while when the total number of the trips decreases, we say that the device is a secure one, as it trips the circuit less number of times, so it's a secure one in general. More than great. So that's about this tutorial at which we explained the first 3 properties of the protection system. Hope that's clear right now. Thank you for watching and see you next tutorials.